Okay, again we have a radical on both sides. We've got the one on the left isolated, so we're going to go straight to squaring both sides. The left side is just x. The right side becomes, as you know, a FOIL problem. Root x plus 5 plus 1 times again root x plus 5 plus 1. Okay, left side stays x. Right side, radical times radical undoes the radical, leaving x plus 5. Outer term of FOIL, I'm going to draw some arrows this time, is radical times 1. Inner is 1 times radical. So we have one radical and one radical making two radicals. So plus 2 roots of x plus 5. The L term of FOIL, 1 times 1 is 1. Okay, here we go. I'm going to subtract x off of each side again, and I'm going to combine the constants, the 5 and the 1, together. So the left side is 0. The right side is now 6 plus 2 roots of x plus 5. And now I'm going to subtract off that 6 to the left-hand side. We're going to have negative 6 equals 2 roots of x plus 5. And at this point, my mind is seeing something. After I divide through by that 2, I'm going to have fully and completely a radical equal to a negative. And no matter what I plug in for x, add 5 and square root, that must equal a positive. So right off the bat, I'm just going to go no solution, looking out for square roots equal to a negative, which is bad news for us in this problem. Here we go. We are going to need to isolate one of the radicals, and I'd rather not have that negative in front of the second radical, so I'm going to add that to both sides and bring that to the right. The left side is going to be square root of negative 15w minus 31, and on the right I'm going to actually write this first, root 3w plus 32, then minus the 3. Okay, we've got a radical by itself. It's now time to square both sides to lift off that radical on the left. So we're going to have what? Negative 15w minus 31, and on the right we're going to have a FOIL problem. Root 3w plus 32 minus 3 times root 3w plus 32 minus 3. And let me check to see. Oh yeah, you can see the whole thing there on the screen. Wonderful. Okay, left side, keep as is. Right side, we're going to actually do the FOIL. The radical times the radical squared, undoes the radical, and out pops 3w plus 32. Your inner term of FOIL, you can see easily, is negative 3 times the root. The outer will be root times the negative 3. So we have negative 3 roots and negative 3 roots, making minus 6 root 3w plus 32. And the last term of FOIL, negative 3 times negative 3, makes positive 9. Okay, so now what we have is a radical still in the problem. We need to do some cleanup. So I'm going to subtract off that 3w on both sides, and I'm going to save myself a line of work. The 32 and the 9 combine to make 41, and I'm going to subtract 41 on both sides also. So we're going to have negative 18w minus 72 equals negative 6 roots of 3w plus 32. I don't like all the negatives, but I do see that if I divide through by negative 6 everywhere, those negatives just disappear from the scene. So I'm going to be left now with 3w plus 12 equals the square root of 3w plus 32. Whew. Now I'm going to slide this up a little bit because I'm going to need some more space on the screen. Okay, now we still have a radical in the equation. It's isolated, and it's time for us to square both sides yet again. The left side is a FOIL problem this time. 3w plus 12 times 3w plus 12. and on the right that is going to just equal 3w plus 32 as the radical gets squared away. Okay, doing the FOIL problem, we're going to have 9w squared plus 36 and plus 36 are going to make a plus 72w plus 144 equals the 3w plus 32. This is a quadratic equation needing to be set equal to 0, so we're going to subtract off the 3w from both sides and subtract off the 32. That's going to leave us with 9w squared minus 69 plus 69w plus 112 equals 0. At which point we need to solve this quadratic equation. I hope that 3 can divide out, but 3 does not go into 112. So we're going to have to break this baby down somehow. I'm going to guess 3w times 3w. I know this one's a little bit more challenging. I got to play around with that 112. Now I know the answer, but for your purposes I'm going to play around with a factor tree. Here's a 112, or factor pairs I should say. 1 times 112, 2 times 56. 3 does not go in, but 4 does. That's 25 plus 3, 28 times. Okay, 3 did not, 5 does not, 6 does not, 7 does go in, it turns out, because 7 goes into 24, and we get 7 times 16. And it turns out, after a bunch of work, that those are the two numbers, 7 and 16. They both need to be positive for this to work, and so we get two solutions of negative 7/3 and negative 16/3 that then need to be checked. Now, so that I can check this easily, I'm going to rewrite my problem down just beneath this line here. We had at the original outset of this problem square root of negative 15w minus 31 minus the square root of 3w plus 32 equals negative 3. So there's our original problem rewritten there. Now, I know we don't like to do this, but we're going to have to do this by brute force. Negative 7/3. When you plug that negative 7/3 in, the negatives are going to cancel, making positive. The 3 will cancel with the 15, making 5. Times 7 is 35. 35 minus 31 is 4, and the square root of 4 becomes 2. Negative 7/3 here. The 3's are going to cancel. So we get negative 7 plus 32, which is 25, square rooting to 5. Is 2 minus 5 equal to negative 3? Yes, it is. And so negative 7/3 does check. Now, when I substitute in the negative 16/3 into this position, we have a major mess. The 3 cancels with the 15, making negative 5 times negative 16. That becomes 80. 80 minus the 31 is 49, and the square root of 49 is 7. Now we plug the negative 16/3 into the next position. The 3 cancels there, giving you negative 16 plus 32, which is 16. That's going to square root to a 4. 7 minus 4 is not negative 3, so the negative 16/3 will not work, and negative 7/3 is our only solution to that problem.